stage, potentially, where we could do some manual exploratory testing, and we might promote it then up to staging, to do some final sanity checks, and then ultimately we're in production in front of real users. So if we take a snapshot in time, then at any given time, we're going to actually see different versions of our software in different environments. Obviously, the closer we get to production, the older the version will be. So what does that look like if we've got two systems that are integrating with each other? We've got a provider of a service here, and we've got a consumer. So similarly, we've got sort of developers working on these systems, and we're testing them in CI. The difference now, of course, is part of that continuous integration is actually to integration test the collaboration between those services and make sure that they actually work together, that the version of the code that you've committed for the provider and the consumer actually can work together. And if they do, typically what we do at that point is we would stamp it, essentially create a release candidate, some version that we could promote through other environments, with confidence that actually when that reaches production, it will work there. So similarly, in this case, we would see different versions in different environments at any time. The question is, does that scale? So let's look at what happens if we start to kind of increase the number of services that are collaborating with each other. So in this case, we've got 4 services, and again, we're cutting a release candidate in our continuous integration environment. But the problem that starts to emerge as we increase the number of services is we get a slow build and test phase. So this step is only going to be as fast as essentially the slowest activity that happens in that phase. We've got to compile different components, we've got to test them together, there may be some orchestration involved, and as you add more services, that's going to slow down. And clearly that's going to lead to development delays, and what we often see is developers queuing and waiting to get their changes into CI, and that's just going to slow down on our feature delivery. So a typical response to that most organizations would go for is then to obviously split up the continuous integration builds and dedicated builds for each component, and we can sort of version each of those different components separately, and now the developers are happy again. Now they're actually able to push commits far more frequently, and they're not waiting on other teams' builds. But ultimately, all we've done is we've pushed the problem downstream. So we've now got downstream integration testing in a later environment, and again, we would probably create some kind of release candidate at that point and promote that through. But as I say, you've really just shifted the problem. At this stage, you're going to get a slow integration phase, and I'm including in this case the sort of manual exploratory testing that QAs might do, and that's going to increase features. That's going to lead to a longer feature lead time again. Additionally, if you get past that stage, when you go into staging, you can find that sort of at a later stage, if there's a problem with one of those components, it's going to fail the entire release candidate, and so essentially you've got to start all over again. And finally, if we actually know that we're going to be delivering some software with confidence and we feel we can go into production, we're still going to be deploying a sort of monolithic approach, and that means we're deploying more changes all in one go, and that's a riskier thing to do. We're actually changing our production system, and we're trying to do multiple things at the same time. So I'll give you an example of a project I was on. So I'm a consultant, I work with ThoughtWorks, and one of the projects I was on was with an academic publisher. And at this particular client, there were already various systems, so there was a content site that essentially served the sort of academic articles and books, and you could read them there. And behind that there was a user service that kind of took care of sort of authentication and authorization, and there was also a reporting service that you could query to find out how many of the articles had been downloaded in a given month, and things like that. And the project I was on was building a librarian portal that essentially integrated with these 3 things. Now this particular client essentially had got to that first stage where they wanted to split up their continuous integration into separate builds, and so the developers of these 3 services essentially could look at a build dedicated to their system and see whether their changes had broken anything. But then they had the downstream integration, and they were creating that release candidate from integration onwards and progressing it through the system. And in terms of the sort of rate of change in that system, they were going into production on a fixed weekly basis. So once a week, they would essentially promote whatever was in staging into production. And similarly, as we went back through the system, they were promoting what was in QA into staging on a fixed weekly basis. And then daily sort of ad hoc deployments by QAs into the QA environment, and hourly ad hoc deployments in an automated fashion from a continuous integration environment into integration where the integration tests were run. And so we didn't really want to get stuck in this syrup, because this would essentially mean that it could take up to a week to get our changes through, and if there was a problem with something deployed, it would be a matter of having to go through some hotfix exceptional route to actually get that bug fix out. And essentially, we wanted to go out much more frequently than that. So we sort of got buy-in to essentially independently deploy through these environments, and essentially, just assert on what our integrations look like as we reach these different environments where we integrate into different systems. But there was a problem that emerged from attempting to do this, and that was that if you look at the version numbers of our system and the release candidate that we met in production, that was the first time that version 26 met version 35. And so we had low confidence, actually, that our system would work when we got to production. So really, we were starting to worry about, okay, how do we track version numbers? How do we figure out if we've tested this enough? And we took a step back and sort of just thought about this in more general terms. So here we were, we had a consumer, version 26, and there was some version of the provider unknown to us. And an example of the sort of interaction we might have, so we might make an HTTP call to get cities, and the provider might return some JSON here. So this is a JSON array of city objects, where there's a name for the city and a country for each city. And one thing that is always true whenever you're integrating with a provider, there's some kind of contract, there's some kind of implicit contract, something that it may just have evolved through conversations with the other teams, or it may be through documentation that that team has provided you with. You have some essentially implicit expectations around the way the system will behave when you make a certain request of that provider. So what we thought we'd do is essentially codify that. Sorry, I'll skip back from that. So, what we thought we'd do is basically stop worrying about version numbers and start worrying about whether the provider that we were integrating with actually met the assumptions and the expectations that our contract specified. And we decided what we'd do is codify that contract in what we call contract test. So essentially, we could run that contract test against any environment and assert that the provider met the expectations of the implicit contract. And we packaged that with the application and stamped it essentially so that we knew that if version 26 of the contract test passed against the provider, then we could deploy version 26 of consumer to that environment. So looking at a particular example of this, in this case, I think this is some C# code. So this is a test that just says cities endpoint should provide city names. And you can see it's making an HTTP call to get cities, and it's checking that the response body is a JSON array, and essentially it's asserting that one of the cities that came back, or one of the objects in that JSON array has a name London, and one of the objects in that JSON array has a name Paris. And some of the characteristics of this kind of contract test are that it's written in the language of the interaction, of the actual contract, rather than the language of the consumer. So there's no domain code from our side in this. There's no sort of layers of abstraction that might make it hard to interpret failures here. It's very much, what do we expect from the other system? It was developed against a real version of the external system, so that the developers could write this test and constantly check that actually it passes against a real system. You're able to set the base URL for the provider before you run the test, so you can essentially point this test to any environment you want, be it QA or staging. And one of the practices that we followed was to maintain a test suite, these contract tests per external system. So we could essentially choose when was the right time to run these particular contract tests for one of these systems we integrated with, because we had multiple systems that we were integrating with. So the question for you guys is, what would cause this test to fail?
There's no London in the JSON.
Right, so if the data in the remote system isn't as expected. So one of the things that writing a contract test like this reveals is the fact that you have to have some stable data in the environments you're going to target. And you're going to have to think about how to ensure that data is stable in all the environments you want to run that contract test against. Is there anything else that would cause this test to fail?
If the property name changes to something else.
Yep.
Or is removed.
Right.
The new version of the URL could be appreciated, or could be /v1 now, /v2 and
Yep. Anything else?
And the Jackson answer?
Yeah, certainly. They just decided to return a completely different media type. So most of those things, barring the actual data, are things we care about. If any of those things changed, we'd want to know about it before we went live. Those are all important and salient details of the implicit contract that we assume when we integrate with this provider. What you'll notice is there's nothing extraneous in here, really. There's nothing that we don't care about. We're not checking on for example, the country of the city, that isn't something that's important to us. And so the provider is free to change that, and it shouldn't break this test. So that kind of thinking is really, it comes from a place of thinking about flexible contracts. How can we ensure that we protect ourselves from the changes that are happening in the provider systems? We don't want to have a test that's brittle. We don't want to have an integration with that system that's brittle. We want to only have to essentially go in and modify this whenever it's meaningful to do so. So when you integrate with external systems, there are some things you can do that will help you maintain a sort of flexible contract or a sort of a weakly coupled integration with that external system. So the first one is a pattern called the tolerant reader. So in this example, you can see that we care about the name property, but we don't care about the country. And essentially the idea of the tolerant reader is you bind to that part of the contract or that part of the response that you actually care about, and you let the rest of that response vary as much as you like. It shouldn't actually cause you to fail when you call that system. And so they're free to remove the country, to change its name, to change the data type, to move it somewhere completely different. So long as the name property is available in each city object, we're fine. The tolerant reader pattern is a specific implementation of a more general law, which is Postel's law, also known as the robustness principle, which is that you should be conservative in what you send, but liberal in what you accept. So in other words, when I integrate with a provider, I can't be sure that they will accept my slightly fuzzy version of the request body that I'm sending to them. So I better be strict with what I send. I better send exactly what they've asked me to send. Conversely, I can't be sure that those guys are going to return exactly what they said they'd return. So I should be as flexible as possible and essentially as accommodating of the responses that come back. And thirdly, if you're a provider, thinking about evolving your APIs with backwards compatibility. So not requiring your consumers to essentially release at the same time as you, but actually giving some flexibility in terms of the responses so that they don't need to migrate as quickly as you're changing your API. So an example of that would be, if I am going to rename the name property here, maybe I'll introduce a new name property. Let's say I'm capitalizing the first letter. I won't remove the old one. And then when I'm sure that all the consumers have moved on to the new property, that's when I'll remove the old one. So that's a way of essentially maintaining backwards compatibility for a sort of range of releases. So if we go back to the example that we were looking at before, here was our librarian portal. We were trying to get version 26 out, sort of independent deployment for these environments. We were meeting different versions down here. And as I say, having thought more about the contract and having codified that into a contract test, we stopped worrying, we'll say, about the version numbers in those systems. And instead, post-continuous integration, our contract test was run against the production system that we were ultimately going to deploy to. So this gave us a sort of early heads up that if we were to progress the version that we had in the integration environment all the way through, it would work when it met production. We started thinking about this less as a kind of integration test phase, but more as a contract testing phase for us. So we didn't look to run time-consuming integration tests against the system in that environment. But obviously, if we don't integration test, this provider might be trying to do a release as well. How do they know that they're not going to break us when they go out to production? They're not getting the feedback anymore from the integration tests that we used to run against their system. So essentially what we would do was provide the contract tests that we've written to that provider so they could run them. And specifically, we asked them to pick up the production version of our contract tests. In other words, the ones that match to the version of our application in production, to pull back to their contract testing environment and essentially to run against their systems to give them early feedback in case they couldn't progress this release candidate through to production. So something that's important when you're sharing contracts with other teams is to make sure that it's easy for those teams to run those tests. You're potentially going to meet some resistance. You're trying to make it as easy as possible for them to run those tests. And additionally, you want to make it as easy as possible for them to understand when those tests fail. So that goes back to what I was saying earlier about writing those tests in the language of the interaction, not putting layers of abstraction above it that involve domain concepts from your application. Hopefully that should minimize the number of phone calls you get from that team asking you why the tests are failing. So just a slight diversion, but it's interesting to look at what happens when a provider has multiple consumers. So in this particular case, we've got 3 consumers and a provider, and if we take that city's endpoint as an example again, let's say this is us, so we rely on the name property in each city, and consumer B relies on the country property in each city, and consumer C relies on just the first city that comes back. Let's assume there's some kind of ordering to this API. So the provider can collect all of these contracts from all of these teams, and so essentially think about it in aggregate. So for them, they have to adhere to every part of that JSON response. They have to provide a first city that comes back with the name London. They need to provide city names. They need to provide country names. But what's interesting about this is this, what we call a consumer-driven contract. Essentially, we've collected the contract tests on different consumers. Is that it defines the obligations that the provider has to its consumers. So that the provider now knows exactly what they should provide, and they're not thinking so much about what they want their API to provide or extra features that no one's using. They are just thinking about what people actually use. And that's really helpful when it comes to making changes to this API. So if the provider is going to make a change, then essentially they can understand what the impact is on the consumers. So again, in the case where, for example, they were going to change the country property, they were going to rename it, they have to get in contact with consumer B and C, but consumer A wouldn't be in the least bit concerned about this. So back to our example. This is interesting. It means that both the librarian portal and the other systems can get feedback at the contract testing stage that that particular version they've just built will work in production if they get it out there right now. But we know, of course, that it can take a while, potentially days, to get between the contract testing phase and out to production. And in that time, the system that the contract tested might actually have changed. So it may not be the version that the contract tested at this point. And that can affect us as the consumer, it can affect the provider. So in addition to kind of looking ahead to give you that heads up, you also want to check sort of each environment as you go. So to illustrate this, if we kind of got all the way to staging and we run our contract tests against production when we were in the contract testing phase, we'd now be about to deploy to production, and we potentially have some uncertainty. It might be the case that the production systems have changed. So we could run the staging version of our contract tests against production just in time, essentially as part of the deployment process. And that would act as essentially a hard gate. We'd abort the deployment if that didn't work. Additionally, the provider would face the same concern, and they can pull back the contract tests from production just in time and run those just before deployment. So this is kind of part of being a good citizen. Every environment that you go into, if you break it, you may be impacting someone else. So let's say QA is a shared environment. There are other teams doing work in that environment to test their features. If you deploy the latest version of your application and it breaks it, that's going to ripple out throughout the organization. That's going to have an impact on other teams. So, a citizenly approach here would be to actually contract test every environment before you deploy to it. So you check just in time that environment works. And similarly, the provider can pull back any of its consumers' contract tests and do the same. So that's nice, but is it the earliest feedback we can get? We get to this contract testing phase after we've been writing code potentially for a few days, and after we run our CI build. So there are steps in advance of this that maybe could provide some feedback. So here's an example. We've got the librarian portal and we've got the content site, and they're both coding away and then committing to continuous integration environment. But at some point later, they're going to integrate with each other, and they might have diverged. It might be that the API has changed in such a way that it breaks librarian portal. And what we can do, now that we've got a contract test, is essentially run the latest contract tests against the latest builds. And that can be something that we initiate, it can be something that they initiate. What's interesting about this is, if that contract test fails, it doesn't necessarily mean that it blocks a deployment or a release or a promotion to a later environment. It could be that it provokes a conversation, we speak to the content site team, they've made a change, they're not looking to go live anytime soon, and actually our system still works against all the environments after this point. So we contract test the later environments, and it turns out we can proceed ahead. So really this is kind of like an early warning system. It's a kind of alarm bell to tell us, okay, teams are diverging, the systems aren't actually converging in terms of their API. And if you can get the providers to run that, then great. But if you can't, then as a consumer, you should run those tests periodically. So something I've done before is essentially have those contract tests running from Monday 8 in the morning until Friday 6 in the evening, during the hours that I can actually respond to failures and have conversations with other teams, and I'll just be hitting a shared environment that they provided to us. So a place where we did this was another project I was on at an insurance company. And in this particular case, they'd gone beyond that point of essentially creating a release candidate and promoting that through their environments. They had felt that pain of essentially fanning in and waiting for integration. And so they had independent deployments across all of their systems. And we came in, and essentially it was just going to be a fact of life that when we integrated with these three systems, those deployments to each of those systems, we're going to need completely different versions of the software. And actually, if you look at the versions of production, we've never met that combination before that point. So we really have no idea if those systems are going to work if we don't use something like contract tests. In this particular case, what we did, again, was we forgot about the versions. We stopped worrying about tracking those. And we ran the latest versions of our contract tests against the latest versions of the external systems. Another thing we did, though, was we had to consider where we were actually going to test the code that we wrote to integrate with those systems. So usually, if you're running integration tests, if you've written application code to talk to these systems, then you'll get confidence that that application code works. And as developers, you might run that against a shared instance of those systems as you're writing the code, the application code and the tests. And then it will probably run again in a continuous integration environment. So we started out on this path. And so we have an integration or functional test driving our customer portal, and that would speak to these external systems. But there were characteristics of these systems that meant that it wasn't easy to do this. So this guy was backed by a mainframe, and that meant that data was quite hard to set up. We had to speak to a team that we weren't even co-located with to get all that data set up for our tests. Some of the states that we wanted to set up were not actually possible. It was a slow environment, and therefore all of our tests, when we were writing code as developers or when we were running the tests in the CI environment, were slow because of that. And unfortunately, sometimes this environment just wasn't available, which just meant we essentially got blocked. We couldn't have functionality. This system, we tried to deploy to our own machines, but it was a completely different tech stack that we didn't have the skill set for. Some of the errors that we sort of cared about were hard to generate. And then ultimately, this system was slow to start, and it relied on other systems, which meant if we deployed this one to our box, we then had to work out the other systems it talked to as well. So there were a lot of things that actually made it very hard to write the tests we wanted to write. So typically, when we are in this situation, we've got, let's say, an integration test that drives a consumer that speaks to a provider. If that provider is painful, we try and avoid it. And in terms of the consumer's architecture, we might have some client code that is the class responsible for making a request and passing the response, and we stop that out. So brilliant, we can stop worrying about the provider. Excellent, we can run our test, that'll be nice and quick, everything's under our control. Problem is that test is only valuable if that stub client behaves like the real system. If it faithfully replicates the behavior of the real provider, then we'll get some feedback that we actually care about. And that means you need to stay up to date with the real system. You need to make sure that you're aware when the provider changes, and then you can update your stuff. But in reality, we don't actually always know when that's going to happen, especially if there are lots of services we're integrating with. It's hard to track all those systems and their changes. And so in reality, we often observe divergent behavior, and you'll see that your stub client just doesn't openly represent the real systems, and therefore you're at risk of writing code that won't integrate when it reaches production. So another approach is to use what I call a fake version of the provider. So what I mean by that is an out-of-process stateful test double. So essentially what we're saying here is it's a system that provides the same network interface as the provider, the same API. It isn't sort of injected into my consumer, and it can maintain state. So we can point at that instead. And that's actually no better than stubbing the client, except for one thing, and that's that we have this contract test. So we're using this contract test to assert the behavior of the provider. And what we can do is we can establish a feedback loop where we run these tests against the external system as well. So what we do is we inject golden data, essentially the data that we know is in the real provider and that we expect to be there, like London and Paris in that example earlier. We inject that into the fake. And then essentially we've got this feedback loop where we can run the contract tests against both the provider and the fake provider. So to illustrate this, the provider might change, it might break the contract tests, we might essentially accept that change as a valid change, update our contract test, run that against the fake and find that the fake's now failing the contract tests, and update the fake. So essentially we've managed to keep these two systems in sync. With that done, we've now got confidence that that fake can be used in our integration tests. And so we might instead inject some integration test data from our test into that fake and run our tests. And in this way, we're actually going to essentially avoid the provider, but not go against a non-realistic system. So some of the characteristics of fakes, they're contract test driven, and they implement just enough functionality to pass the test. So you do not need to implement 100% of the functionality of the real system when you're implementing a fake, but you might implement 1% of the real. behaviour. They're transient, so they don't need to kind of maintain any state between sessions. When you shut them down, you bring them up again. So again, that's leading to kind of a simpler implementation in the real system. They use the same network interface, so that should mean it's easy to swap between the fake and the real system. They look the same on the wire. They're fast to start, easy to deploy. You can put them into the desired state easily, which again can be very hard to do with real systems, especially if there are systems behind those systems or databases behind those systems. And they can simulate failures that it may not be possible to simulate with the real systems, such as a response that's slow. Yeah?
So for those last 2 points, you can't really then use the contract test to validate them because you can't get the actual system into that state.
Yeah, so there are definitely cases where you have to, there are some things that you're not going to be able to do. So for example, if you want your response to take 2 minutes and you can't get it out of the real system, that's just going to be a characteristic of your fake. So there will be some, should we say, some tolerance for behaviour that you just cannot keep in sync with real and fake systems. Yeah, that's true. Another thing is that they respond based on state established by previous requests. So for example, you might create a user with one request, and on the next request you expect to get the user back. What that means is these fakes can be used, for example, in functional or black box tests, where you're not trying to stub every single HTTP request and response. You just want this fake to behave like the real system when you swap them out. So some examples I've used on different technology stacks, for example in Java, Jersey and Jetty, .NET, Nancy and the area HTTP listener, or in JavaScript, Express and Node. So they're very lightweight. It's usually easy to actually embed these in the same test process so they can start and stop when you run tests. So in terms of leveraging these fakes, they're usually versioned with the consumer and the contract test. So you're essentially saying, here's version 21. It's version 21 of the application has version 21 of the contract, which I can run against any environment to prove that that environment will work with version 21 of my application. But I've also got version 21 of my fake, which passes those contract tests, and which I can use to test version 21 of the consumer. So all of these things live in the same source repository. Using them in automated tests, I say, makes those tests a lot faster, so you feel those benefits instantly. Another thing is you get to set up the test data in the test itself. You inject that test data into the fake from the test, rather than relying on some seed data that you assume exists in the real system. And that can be painful. If you're writing lots of functional or integration tests, then actually, understanding the intent of that test is a lot harder if you just need to know that a certain thing exists in a certain remote environment. Another thing that I've seen work well on projects is actually essentially creating a sandbox environment. So being able to set up these fakes in a certain state, injecting all sorts of interesting scenarios for users or data, and then starting your application and using that for exploratory testing. On the projects I've been on, I've seen BAs and QAs and UX folks really enjoy that as a way to play with the system easily without having to change the data in other systems and understand all the technical impact there. As I said before, you can essentially just target this fake by changing the URL. So this looks like the real system as far as the application is concerned, so you're not having to fiddle a lot. And then finally, just a tip really, I would say if you're going to use fakes in automated tests, run your contract tests before you use these fakes for any other testing. So in an automated build, I would run the contract test against the fake, and then I'd run my integration test or my functional test against the fake. Because if you don't do that, and the fake doesn't pass those tests, then the other tests aren't very valuable. So this is what we started with. We moved to a place where we had essentially fakes for each of the systems, and we had contract tests for each of the systems, and we maintained a feedback loop between the fake and the real system. And in terms of our sort of code ownership, our source repository contained the fakes, the application, the automated tests, and the contracts, but obviously not the external systems. So pulling back, these are some of the places in a suite of delivery pipelines, of independent delivery pipelines, where you might use contract tests. So you've got developers using contract tests to help them test drive fakes that let them develop more quickly. Similarly in CI, to let the tests run more quickly. And then you're using those contract tests on the latest builds to get early feedback and looking ahead to ensure that you're going to be able to hit production. And then again, as a kind of safety check, just before you deploy to an environment as a hard gate. So everything's watertight, right? That's it. That's all we need, and we're good. We're on our way. We're not quite. it's certainly possible that you run a contract test and the thing you tested changes before you get there. And obviously, as you scale up the services, the more services you have, the more you're going to have to accept that things will slip through. This isn't always going to cover you. So here are some supporting practices that can help. So the first one is a short lead time. So ultimately, you want to minimize the amount of time between running a contract test against the target environment and deploying to that target environment. You want to get across this pipeline as quickly as possible. Smoke testing, so at some point you do actually want the real systems to integrate with each other, ideally. So just having some lightweight sanity checking tests, potentially in staging or after each deployment, just to give you that sort of thumbs up that these systems can talk to each other and maybe the most valuable user journey works. Deploying in small batches, so for both providers and consumers, means that there are fewer surprises because fewer things have changed between releases. Canary releases, so actually going into production but only exposing yourself to a small amount of the traffic, maybe 1% of the traffic, and checking that the system behaves as expected, means you're minimizing the impact of any failure. And then ultimately, you need to be thinking about designing for failure. So failure will happen, things will break, and ideally your consumers should be able to cope with that gracefully. They should be able to degrade their functionality gracefully and handle unexpected conditions. So I've been giving contract testing quite a hard sell there. It's not a free lunch. There's lots of costs involved. So firstly, there's a learning curve. This is a slightly different style of testing. I would say it's an addition to the sort of suite of tests we already have, but it is a new style of testing, and it impacts the way you build the software potentially. You've got to gain access to the environments that you want to fire these tests at, and that means talking to the people in the organisation that control those environments. You may have to live with unstable environments. Those environments may not always be there. People may be changing the versions or taking them down all the time. So there's some thought you have to give to whether a certain environment is appropriate for this. You need to establish and then stabilize golden data, so the data you expect to be in all those environments, which has to look the same to some degree in all those environments. How do you get that set up? How do you maintain it? If an environment is being blown away all the time, maybe you need to automate that. You need to package the contract tests for your providers if they're going to run. You want to make that as simple for them as possible. As a provider, I don't really want to have to understand the technology stack of all of my consumers. Just give me something I can run quickly. You might need infrastructure to share those contracts with other people. Again, if they just want to pick up a production version of your contract test, they don't want to spend too much time figuring out what that is. They just want to have for example, a URL they can go to download that contract test. A subtle one is avoiding data contention. So if you have multiple developers and maybe your CI box running the same contract test against the same environment, if those contract tests write that data, then potentially it could be changing the same piece of data at the same time. So that's one to watch out for. And then here are some cases where, before we get there, thinking about sort of writing these fakes, there are some subtleties here as well. So the first one is that you can write a fake that very naively sort of passes your contract test, because you've written a happy path contract test. And, for example, it might not enforce the mandatory query parameters you're passing in or the entire structure you have to send, but the real system will have a problem with that. And if you do that, you're at risk of then test driving a naive implementation in your production code. And it'll only be when you go live that you find out there's a problem there. So you have to think about potentially contract testing some of the failure modes as well, some of the things that happen when you don't pass what's expected. So, as I say, an example of that might be, okay, what do I get back if I don't pass one of these mandatory query parameters? Additionally, if you are faking systems that share data with each other, so, for example, OAuth, there may be OAuth tokens being shared between services. Do I now need fakes that share that data between the fakes? One way of coping with that is you build one fake for all of those services. It depends on the shape of the organisation, whether that's going to work for you or not. And then an example of a case where I've certainly found contract testing doesn't apply, or it's probably more pain than it's worth. If you've got a very dense message structure, if you've got a highly coupled integration, so an example of that is SAML, so the security assertion markup language. Big block of XML you have to generate as a request, big blocks of XML you have to consume as a response. You care about almost every facet of that XML. Therefore, can I reason about that integration easily and codify that in a contract test? Is it worth it, or is it just worth taking the hit and running some integration tests there? So there are cases where this may not work. And in addition, you've got to watch out for pass-through systems. So if you've got a system between you and the external provider, which modifies the outbound request or the inbound response, essentially the contract is being spread across both of you and that pass-through system. So in that case, again, maybe you need to contract test through that pass-through system, or maybe it's not appropriate. So just to summarize, contract tests may help you release independently and with confidence if either of the following are true. If the service provider is willing to run your contract tests in their pipeline, because that's enabling them to essentially independently deploy and independently release without having to go through some kind of shared integration environment where they check their API against your system. And then secondly, if you need a realistic fate for testing because the real external system is hard to configure, frequently unavailable, or slow. So in those cases, you want a realistic fate, your contract test provider feedback loop between the fake and the real system. Thank you.
I can certainly see the benefits of contract testing or verifying that the provider is providing the information you're expecting. But how do you verify that you're not relying on something in addition to what you specified in the contract tests?
Okay. So I'd be writing happy path contract tests to obviously just check that if I provide everything that is required, it passes. Yeah, I think I'm.
Yeah. So for example, in the contract test you showed, I'm going to test that the provider provides the CityNet.
Yeah.
How do you, in your process, stop your consumer also relying on the country code? Where does that?
I see. Okay, good question. Okay. Well, actually, what I can do, so I've got some appendices here of things that I've cut out because 45 minutes. I usually give this talk it's more than an hour, so there's more stuff to this talk. But what I can do is I can skip through to the one around the development lifecycle, which would actually demonstrate some of this. But essentially, the developers write these contract tests at the same time as writing integration code. So there's very much a kind of thought process that goes into saying, well, what are our assumptions about the external system? Let's codify all of those. Now, it's true someone could add something that isn't in the contract test in just the same way that someone could write some production code that isn't covered by a test.
Yeah.
So I guess
so where in your development lifecycle would that area show up?
Yeah, let me skip through to that. Okay, so this is an example where we've got an application with three tiers here. So we've got sort of UI or API layer, a domain layer, and then an integration layer which essentially abstracts away all the detail of the integration with the external system. And a typical sort of outside-in acceptance test-driven approach to this would be to start your story, for example, with an acceptance test, and you start your fake before you run all your tests. You'd inject some, sorry, it's getting cut off there. You'd inject some data into that fake for that particular scenario that you're writing a contract test for. And then you'd exercise the application and assert on the observed behaviour, and then reset the fake between each test. And obviously, at the start of the story, that's not going to pass. And then you drill down, essentially drop down into writing unit tests. So you write some unit tests against your UI layer to drive out the implementation at that level, and then similarly at the domain level, and you get that stuff to pass. And then when you reach the integration layer, you stop, essentially. At this point, rather than unit testing, you write an integration test across this piece to essentially describe what it is you expect to get back from your integration layer when you call the external system. So again, you can start your fake, inject some state that you expect to be in the external system, exercise that integration layer, assert on response, and then again reset the test between each test, reset the state between each test. And the first thing you start doing at that point is get that test passing. You start to implement the implementation of the integration layer. And that will start to demonstrate to you what things you're actually relying on. So, oh, I need to call this country's endpoint. Oh, and it looks like I need to pass this query parameter. So that's the point at which you start to understand what those assumptions are. And you sort of in tandem can start writing a contract test against the real provider, which captures those assumptions. And hopefully you're going to find that actually passes. Otherwise, you've misunderstood what the real provider provides for you. But with that contract test passing, you can then point that against the fake, and you can start to implement that behaviour in the fake. So again, you start it, you inject whatever golden data was in the real system, and you implement the behaviour that gets that fake to pass. Once you've got that fake passing, you should be able to start getting your integration tests to pass and your acceptance tests to pass at that stage, essentially. So it's kind of, lots of thin vertical slices through the functionality, and at the point at which you're thinking about integrating the external system, you understand what the assumptions are, and you capture them and codify them in the contract test.
Yeah.
Very early on, you said a lot of the time was taken up by doing the testing, the integration testing. You then go on to say we're going to do all this contract testing against everything. Doesn't that take the same amount of time?
No, not really, because the contract tests essentially decoupling from the other teams. So with the integration testing, there's one environment that we all have to go into. So essentially, we've got a shared point of contention. Only one set of changes can be deployed and tested to that environment at any time before they can move through and the next step can go through. Whereas with contract testing, every team has the independence from their own pipeline to run those tests against any given environment at any time, and if they see that those tests pass, to proceed through.
And if they fail?
Well, if they fail, they usually would provoke a conversation, inspection of why the tests are failing. It might be appropriate for the consumer to respond to that. It might be appropriate for the provider to respond to that.
Doesn't that cause more contentions? Well, your fault saying that's our case.
Well, I would say that it provokes more communication, but ultimately, it may expose other issues that are under the surface. I think you hit those issues anyway when you go into an integration environment. It's just that you're getting that feedback earlier, you're potentially finding out sooner. Hopefully, you can mitigate the cost of that earlier in your pipeline. Yeah.
What's your take on the version of the provider?
So I think that that for me, so semantic version, for example, where you're using the sort of the major number in the semantic version to indicate that there's breaking changes. Things like that, using that as a communication tool, I think should be a kind of a last step, something that you fall back on if you can't get this sort of thing working. So in closely collaborating teams, hopefully you can get those teams exchanging contracts with each other. But if I'm putting out a library to a broader set of consumers, maybe it's been published publicly, then that may be less possible. So I would say that that is another communication tool, but obviously it requires more coordination, more inspection of what is that version. This is a bit more automated.
If you run your contract tests against a live environment, how can you guarantee you're not causing side effects?
Yeah, good question. So I've got another guy I know about that somewhere. So one of the projects I was on, as I said, we did hit production, and what we did was we made sure we had certain safe entities. So in our case, it was a user under which all of the other data lived. So that was kind of the aggregate root for us, and it meant that we knew which users we could hit and modify, and that created a level of safety. We also whitelisted the requests that we could make. So as we added more as we did more integration, also there were new endpoints we were hitting on, new things we were doing in this API, we essentially had to add those requests to a whitelist, which was essentially just a kind of a safety check to make us sort of step back and say, okay, we're about to do something dangerous. And the other thing to point out was that a lot of the calls we were making were read-only, so it was safe. But in a lot of environments, this wouldn't be appropriate. And certainly, if you're working in an environment where the impact is high, or for example, you have compliance rules to sort of adhere to, then you're not going to get that option. And so I'd probably recommend that if possible, there is a target mirror production, which just has the same versions as production. So for example, it might be the case that post-deployment to production, the system is always deployed to the mirror as well, so it can essentially give a guarantee of the same version.
But even if you can't guarantee direct side effects, you get indirect ones, like in sysops side, you fill logs up, you create hits, you affect the metrics of another department reading those metrics somewhere else, etc. So
yeah, definitely. Yeah, so I think there's lots of issues to think about there. I mean, on a high traffic side, contract tests shouldn't massively impact it. You could probably look at ways of identifying yourself as a contract tester and having those excluded from the logs, but clearly there's more cost involved in doing that. It is just easier to go against a non-production environment.